Welcome to Food for Thought. Today is the continuation of the conversation that Valeria and Gilad had about relevance realization, and I dedicate this Food for Thought to quantum mysticism. Enjoy.
There's some temptation with the harder and kind of deeper terms to mystify, and because they're kind of a catch-all for the people who are not really deep in the field.
I think the attraction with quantum mechanics, quantum physics in general, it might be related to science having hit a hard wall on a lot of the things that we took for granted. Because if you take like physics to be the ultimate contact with reality, which is a lot of what I don't know, the Enlightenment, the European Enlightenment mentality is like science will have all the answers, and that's where the answers are, is in the objective facts of physics. And then you go there to the physics and you discover that, well, a lot of the things that we wanted to get to the bottom of, the bottom is fuzzy. So I think part of the attraction comes from the hard science having like gone soft and fuzzy on you, you know?
Yeah, I mean, there's definitely that, and there's, I mean, it was also a part of my attraction to quantum physics, and there's a lot of beauty in that, like, but I think it's kind of the beauty where in every field, when you reach the point where you have to go to like the field that it's dependent on, right? Physics had to go to philosophy, right? When it encountered quantum mechanics, right? You could not stay with the philosophy of, let's say, the Cartesian worldview and like the Newtonian, Leibniz, all of those concepts had to really take significant modification to keep functioning, and that's always fascinating, and it always kind of brings in like the curious minds. And yeah, I guess there's also something about that which is like in this cultural phase where there's like Bernardo Castro calls it this idolatry of nerds, where you have also this motivation to say, like, you don't know everything. Look, quantum theory surprised you, scientists. I mean, yeah, there, you know, it's a thing, right? When you can sort of, I don't know, catch scientists with their pants down. Right?
It's more than that. So I'm very well aware of my ignorance in quantum physics. So normally my response is like, I don't even try to understand it. But you still hear things here and there that are attractive to people, right? So there is this thing with uncertainty.
The uncertainty, right?
Where the fact of you looking at it changes the thing that it's looked at. That is powerful. I hear some transjective vibes even there. You know? It's just killing up the. No, but really, if you think about the attractiveness there, if a mind that is grasping for something that is transjective, for something that, no, I cannot separate the observed and the observer. And you are caught in this frame where science is the king, or science is the only thing that is valid. And then you go to the physics, and the physics gives you something that, hey, look at that. You look at it and it's different because you're looking. That is very attractive.
Yeah, I get what you're saying. I mean, and I guess my own
I'm not defending it.
My own experience with that is when I was a teenager and I only knew a bit of quantum mechanics, you know, from high school, and we don't study it extensively. There was like a guest lecture that we went to, and I saw this pop science movie, which turned out to be a pseudoscience movie, but I was really captivated by it. Right?
Which one?
It was What the Bleep Do We Know? And it was about quantum mechanics and quantum healing and all those things. And I was like, wow, all these things make sense. They were utter bullshit, right? At the end, like I can say today how they were bullshit, but like they are really captivating because they tell you. So for instance, one thing is like you look at something and it's different, and that is one of those points that until you get really down to quantum mechanics, it's really hard to explain why it's not that this is not true, it's just it's so much more complicated. And I can give a small example, right? So if you perform a measurement on the system, which is supposed to like change its behavior, right? And no one ever looks at that measurement, right? It has still happened, and the thing would change its behavior according to the fact that it was measured. And like the formalism is to say that actually, if there's a trace on the environment that has changed, like the environment in a way that is distinct from that event not having happened, then that's enough. Like that's enough to change the outcome of the result. And people have this. Now, at the end of the day, there's a lot of reasons to say, well, you couldn't have known that for sure, except by having conscious agents, saying this or that. And I've actually studied under Lev Weidman, who is an advocate of the many worlds interpretation, which is every quantum event splits the world in however many results it has, and it's also fascinating because like his motivation for following that is not because he likes sci-fi movies, but he thinks that it's, let's say, the least intrusive change to Schrodinger's equation is to assume that there are many worlds, and that way you don't have to like insert something like the wave function collapse. And so that's why I'm saying like it's fascinating because of that intersection. Like you have to talk philosophy in a way. When you get to quantum fundamentals, you have to start thinking about all of these things, like whether that's consistent philosophically, whether the right thing philosophically is to follow our intuitions or to change the mathematics as little as possible. Like what at every level of that, you have real questions that are fundamentally undecided and outside of the realm that science feels comfortable in.
Science depends on the kind of science that you're doing. It will feel comfortable with anything.
Yeah, but I mean, like all of those things feel really arbitrary to a scientist.
A good scientist.
Yeah. And
because scientists do reify things and do take things more seriously than at least I've worked with scientists that would take, for example, so the field was neuroscience, and then you take like an operationalization of a concept, which will give you a number, and forget that that number is not the thing that you're talking about. Like that operationalization of the concept of empathy, like how many points you got on this game that, or say, where you have to have the chance to give things to other people. That is not altruism. That is a measure that can give you a hint of how altruism can change with meditation. That's not altruism. But the people treat it as if it were. So let's not take scientists off the hook too quickly here, because they do like to. I have seen instances in which the scientists were using science in a way that did not seem very. It was stretching the boundaries of what science can be responsible for. Let's put it like that.
Absolutely, and I think there are many examples of that. So I'm not putting scientists off the hook. Right? I'm not trying to say that. I'm just
we're talking about good science here.
Yeah. But even in that sense, my point is there are also good scientists who do great philosophy, and like P.W. Anderson is a great example. He wrote the 1971, I think, article, More is Different. He's a Nobel laureate, or was. I don't think he's alive. Like that's pretty much a philosophy of science article, and amazing, and it kind of talks about a lot of what John talks about with sort of a flat ontology and emergence, and how reductionism doesn't imply constructionism. Like even if you know all the rules by which atoms interact, you don't know the rules of chemistry. Like 10 to the 23 atoms are very poorly explained by looking at every interaction between every atom and every other atom. And they're much better explained by a picture that looks at this moreness and, let's say, discretizes it differently, rather than saying it's all just atoms. Because it is all atoms, but it's not just atoms, right? It's all of those interactions are much more than the constituent particles, even if nothing disobeys those particles. But you can't, and that's why I say it's not constructionism, you can't just look at them and say, oh, I know how two atoms interact, I know how to add a third, so I definitely know everything that would happen when I put 10 to the 23 of them in a box. Like, you don't, you really, like, everything that happens is new, and you could not have predicted it, and you don't know what it will be. So it's ridiculous to kind of say that that it's like nothing new. And in that sense, it's very much like what John is saying about the different layers, or the different degrees of, or lengths of length scales and stuff like that. Different scales of systems have to have similar ontological realness. You can't just say, oh, only the atoms are real, or only the quarks are real, and like all of this is just phenomenon that arise from their interactions, because what would that even be useful for?
There are two things that I'm thinking right now. One is that Joscha Bach saying that trying to understand the mind by studying neuroscience is like trying to understand flight by looking at feathers under the microscope, which is something that's like, yeah, I wish that he had told me that before I tried to study neuroscience and discovered that there was no mind there.
That really reminds me of Franz Rosenzweig. It's like a very different direction, but he's a Jewish philosopher, and he said that trying to understand experience, he was talking about religious experience, but experience through knowledge, he gave two analogies. It's like trying to study a river by making measurements on a sample of the river's water, or trying to understand a tiger by looking at its corpse and studying its corpse. And it's like the experience, like the actual lived world, and in both of these cases has all of that, dynamic, and all of that aliveness to it. And when you're, after the experience, reporting what has transpired, you have none of that. Like, by definition, you cannot capture that dynamic, because you're not in that dynamic. And that just really reminded me of the same analogy, right? This kind of scientific thing, when you're looking at a component, and like, you can know some stuff about the river from studying its water. You can know if it's polluted. You can know, maybe where the water is coming from the, I don't know, composition of minerals or whatever. But it's not the river. right? There's so much you don't know about it by measuring something about its water.
Yeah, but one thing is, and that's back to what John is putting at or explaining at the Awakening from the Meaning Prize, we kind of have painted ourselves into a corner, and then we kind of jump between the corners where we think that the reductionist is the way, and then and when it's not sufficient, we kind of give up rationality altogether and just go to the romantic way, and like the unconscious and the feelings and the animal nature, and the thinking mind is getting in the way of you seeing reality the way it is, and all this. I'm kind of interpreting a lot on what John is saying. Do you think I'm being fair?
I think you're being fair. He speaks a lot about those extremes, like how romanticism is, or even Kant, like saying that because we cannot see the thing in itself, then the romantics say, oh, so like we need to stop being rational in order to break that filter between us and the world.
So there is in one thing that I am undecided about myself is that for somebody who is in that corner and looking out of the science corner and trying to bring in different things, but still does not have a framework that can encompass good science and different aspects of their experience. I think that's the crack through which like quantum mysticism gets in. And that's a good term. We can talk about quantum physics and quantum mysticism and then separate them.
Yeah, quantum mysticism is a really good term.
Because, for example, people talk about entanglement. That's another one that's very popular. There is a reality that everything is interconnected in a way. And well, we isolate things with our minds, we isolate things with our cognition, but in a way everything is connected to everything. For example, if I move this cup from here to here, I'm dislocating air, and I'm dislocating air in this room, and that, I don't know, that's maybe a crap example, but
it's a reasonable example up to, you know, chaos theory or whatever. What are you getting at is the question.
What I'm getting at is that people hear about things influencing each other through large spaces and being bound forever, and that's a reminder, that's a symbol for this interconnectedness of everything. And it has the pseudo blessing of science.
Yeah, there's an interesting thing about entanglement, which I think is the most misinterpreted term. It's like, the interesting thing about entanglement, like people think, oh, now it's entangled, it's together forever. And it's like, it's exactly the opposite. And like, this is a problem with quantum computing. Like, it's entangled and it's really easy to break. Like, it's really hard to keep it entangled. And then even if you do, once you use the resource, let's say in quantum computing, like you entangle some qubits and then you measure them in order to do the computation, that's it. They're no longer entangled, right? And that's what happens to basically everything, right? So things are just like not entangled. Is the natural state of things. But it's like, it's an amazing thing. It's an amazing phenomenon. And then like,
I don't really know what the real physics is.
It's interesting because it's the same claim in that bullshit movie that I watched, right? Because they tell you about entanglement, all valid scientific things, and then they say, and now think about the fact that all of the particles were in the same spot at the start of the universe, and you know that means that actually we're all entangled, and that is complete bullshit, right?
And symbolically beautiful.
Yes. and no, but yeah, I get what you're
Oh,
saying.
come on.
I mean, there's something about
Think
it.
think about the one. Think about the nothingness from which everything emerges. Think about the Wuji, the thing that split into the yin and yang, and then the Daiji and all this kind of things, like the origin point of everything. That's symbolically very powerful. It shows up all over the place, and now in science mysticism.
Science mysticism, yeah. No, I get that. I just think that it's a kind of truncated symbol, right? Because when you think, for instance, about the yin and yang, that's a deeper symbol than like a point in space where time is not even defined, and then massive explosion and inflation, like the symbolism and the thing, like even with the fact that they're all entangled, like there's something about it to me that kind of feels like it's a proxy to symbolism. And that's I mean, that's what scientists in many cases are hungry for, right? Because of the Cartesian worldview and everything. So yeah, Star Wars, Star Trek, and quantum mysticism are proxies for the scientifically minded way. Because like I've only read one of the passages in Religion and Nothingness, but I think like when Nishitani talks about the religious quest and the deep nothingness and how it relates, let's say, with Western nihilism and all of those things, that's despite how hard it is to figure out what's actually there. Nishitani is pretty hard. It's a very deep symbolic world that he's engaging with, and I think science doesn't have the richness, like when you not science mysticism is what I'm trying to say. It doesn't have that richness. It's kind of like when you try to dig a bit deeper into the yin yang, like there's this kind of depth that you're constantly taken by into that ground of being. Whereas when you look at tangled particles at the start of the universe, you get maybe a warm fuzzy feeling inside, and that's pretty much it.
Yeah, I've never been attracted to science mysticism myself in any way, but I need frameworks to be able to respect and relate to the people who get attracted by those things and talk about those things and take it seriously.
Yeah.
Because my reaction to it is not very I feel a certain kind of repulsion towards what's happening there, but trying to get at the deeper truth. There's the story of the person that saw the wind turbines and thought that they were big fans to cool the earth.
Yeah. To me, Feynman is a great example of kind of a ratio religio, I could say, in terms of his philosophy of science. He says at some point he's asked, are you looking for a unified theory of the universe? And so, my point is to explore nature and to see what is. If it turns out that the thing can be explained by one theory, okay, then that's the way it is. And if it turns out that it's like, he said, like it's like an onion, an infinite onion with layers that you just peel off and you never, reach the bottom, then that's how it is. But whatever it is, nature is the way it is, and she will reveal itself as she is, right? And all our efforts are aimed towards that. Today's, like a lot of people, work on that. I don't think really in my experience with people doing science, because people doing science don't generally bother with philosophy that much. But like the philosopher scientists, a lot of them are kind of around, oh, quantum gravity, or a new standard model, or maybe space and time are not fundamental, where people are talking about it. And to me, those seem to be kind of more around those kinds of let's say motivated searches, right? I want the world to conform to some sort of beautiful formula, rather than I want to be able to understand a bit more about the world and see what it is. I don't know what it is. So I think those are two approaches, like from long standing. By the way, I think Einstein was also on the other path. Einstein said, I look for beauty in my equations. And I think like Feynman and Einstein would probably be on opposite ends of that.
Yeah, the thing with nature is, so when we talk about nature being something and us getting in touch with what nature is, we're talking about intelligibility, right? Or not?
We're implying it, I guess, because we're implying that there's at least some element of nature that is intelligible and that we could comprehend it because it is intelligible.
Do you think that there is only one way in which we can comprehend nature? Given a certain phenomenon, comprehending it, downloading the phenomenon, or uploading the intelligibility of the phenomenon, conforming our mind to it, or whatever.
I don't think there's only one way, but I do think that different approaches have different, let's say, consequences on what the search is.
Yes,
that's all I'm saying.
And some are better than others. Some approaches are better than others.
I feel more connected to than others. I don't feel when I look at like scientific developments, I don't feel the need for there. And there are people who say like, oh man, unified theory. Oh man, there's problems in the standard model. We have to find the thing that explains everything. And I don't share that emotionally. Right? I really like to just, do my thing, right? And just like, oh, look, here's a thing we didn't know. That's cool. Right? It doesn't really, connect with me in that way. Now, think like there's a lot of fields, probably much less in popular science, where there are, I don't know, 5 different interpretations of what, like, we know the phenomena, we do the experiments, we know to predict them, and we think about that in very different ways. We make it intelligible in very different ways. And I think that's inevitable. And even about that, Feynman talks about, and he says something that I also think is really interesting and profound, even outside of science. He says, like, if you have 2 interpretations that you can prove mathematically would give the same results in all of what we know about the theory, the experiments, and everything, like, so they're completely equivalent in the math, right? Then what do they even matter? Does it matter which philosophical approach you take to that, which interpretation you believe in regarding the theory, or you adhere to? And he says, what you need to be able to do, and I think you'll connect to this, is you need to be able to switch between the different interpretations, because they're going to give you different intuitions. If you're exploring somewhere outside of the theory, and not within the results we know, then a thing, he says, that could be just one element in this theory could be like 16 different interconnected things in another interpretation. And if you can move between them as flexibly as possible, then you can have better intuitions about what would happen outside of what we know. And I think that coheres with whether they think philosophy in general, or like what you were saying about Confucianism and Taoism, right? This tension, are those the two we're talking about? Like when you said that in Chinese culture they had Confucianism and was it Taoism or Buddhism?
They had both, but Confucianism, Taoism, they kind of oscillated. So the texts that we refer to as Confucianism, the texts that we refer as Taoists, they actually have like there's one Confucianist, and then a Taoist response, and then a Confucianist response, and then a Taoist response. So we're basically pairing.
Yeah, but I think your point was like they're holding that tension. Like
Yes.
The cognitive grammar of that culture is, how do you hold those two interpretations of reality?
Yes.
And not like commit and delete one of them. And I think, in analogy, that's something similar to what Feynman is saying. Like if you can jump between them and say, like, let's look at this through the lens of that theory, let's look at this through the lens of the other theory, then you can have much better intuition, because some elements of reality, even if they're equivalent at the end, like you can prove mathematically, they're much simpler or much more direct in one interpretation than in another. And we're humans. We don't have like some access to godlike powers that would let us just see through that. We need intuition. We need simplicity.
Well, the mind created physics.
What do you mean?
The science.
The mind created the science of physics.
Yeah. The mind created the instruments, the mind created the mathematical language.
I mean, mind, when you say mind, it's not like one individual's mind, right?
Mind, yeah, minds.
Yeah, okay.
I'm talking about the fact that
I mean, minds and culture and all of those things.
Like physics is not a property of physics. The science is not a property of nature.
Okay.
The science is not something that exists in nature and we just discovered it. We have the inventio is what John would say here, is to invent / discover the language, the patterns, the instruments. There's the top down and the bottom up conversing there at every level. So
yeah,
we create languages, and with these languages we create models, and with these languages and models we create instruments, and then we measure things, and then we make connections. But the top down is there from the beginning. So
top down, which means coming from the world or from the divine to us. What is
from the mind and the culture. So we started with.
Yeah, it's just like top down and bottom up are used sometimes in different ways, right? Because sometimes you mean bottom up means from us outwards, and top down means from the depths of reality to us. That's like emergence and emanation. And I think now you're talking about it in terms of top down from culture to the world, and bottom up is from nature to us. And that's interesting. I mean, because nature, like talking about different
things. I might be confusing things. Yeah, I might be confusing things.
Yeah.
Go ahead.
I'm just saying it's interesting that you can think about nature as kind of our base nature.
Yes.
And you can think about nature as the divine nature, and both of them like and you can talk about both angles when you talk about physics, like like emanation from the divine truths, like Plato thought about the forms. Or do we have actually like emergence of a phenomena springing forth and like this top down in terms of we use our minds. I have noticed the time now, and I have to go.
Thank you for being here. Thank you for your time and attention. See you in the next video. Bye.
Most of reality that you experience has nothing to do with quantum mechanics. and it's really unreasonable to talk.
Isn't everything like a quantum field? Aren't we living in a
Aren't we?